All right, live from Soho, New York City, it's Wearable Electronics with Becky Stern.
Hi, I'm Becky Stern. Welcome to the show. With me is Phil.
Hello.
He helps run the show and sends out tweets for you to get.
That's right.
Phil, what's on today's show?
On today's show, Becky, we are going to have Electric Halloween, all the things in the world of Halloween for you to make, share, and scare the LEDs off people.
Ah!
We will have an arc reactor-like tutorial.
Halloween.
TM. We'll show you how to make it. We'll show a video, all that and more. We have Component of the Week.
Where we show you a component and how to use it.
That's right. Material Spotlight.
Where we show you a material that you may not have heard of and how to use it.
Yeah, this one is a fun one this week. A lot of people had a lot of questions about it. And Q&A.
We answer your questions. In fact, it's how you can enter to win our show's giveaway.
That's right. And this week we're giving away a
LED sewing kit.
All right, that's a really good one. You actually worked on that, Becky.
Yeah, I designed that kit.
That's your thing.
Yeah. What's the code today, Phil?
Oh, we should have a code, right?
Yes.
Okay. All right, the code.
My name is important too, but
yeah.
the code.
All right. The code today is Halloween to help you get started on Halloween projects. If we do the code on Halloween, it doesn't make much sense because it's over.
So all month long, if you watch my show or you watch Ask an Engineer, each time we have a show, we announce a discount code so you can get 10% off anything in the Flora or Wearables category with code Halloween.
Yeah.
So you can build your Iron Man Arc Reactor TM project.
Yeah.
And get a head start on your electronic Halloween costume.
Halloween, the ultimate maker holiday. It's the one time of year where everyone can participate. Doesn't matter who you are, your skill set. All that matters is you make something.
Yep.
No store-bought costumes. That's not cool.
They're really lame, the store-bought costumes.
Yeah, I remember there was a commercial from a famous shopping store, and they were making fun of the kid who had the homemade one, and it was the best one out of all of them.
Aw.
And I think that was right when like the maker movement kind of like really hit its stride, and everyone was like, "Whoa, the kid and the mom who made the costume was way better than the store-bought one." And so it didn't have the response, I think.
I know, but I think maybe it's turnaround time. My mom used to make my Halloween costume every year. Maybe you want to go to our Halloween graphic.
Yeah.
We'll talk about Halloween coverage on the blog. We're gonna every day, every weekday in October, we're gonna be putting up Halloween posts on the Adafruit blog so that you can get inspired to build your own Halloween costume. But like maybe I'm biased because every year my mom would labor a lot over our Halloween costumes. Thanks, Mom, if you're watching this now or later. One year I was a Hershey Kiss, and she made that out of like silver lame, and like the hat was the tag. And like one year I was Raggedy Ann with like a wig made out of yarn, and like she would just Tweety Bird with the big head.
What was your favorite one out of all these?
There's too many to have a favorite.
Really?
The Scarecrow costume I liked a lot.
That's cool.
But like handmade, but she would get patterns from the store, and so like I can understand that like the sewing companies who make the sewing patterns, they're like a design cycle behind whatever's going to be popular this Halloween. So like maybe that's why the kid gets made fun of for having the homemade costume. But like my costumes always got lots of compliments because they were the best quality ones, and we could wear them year after year. In fact, I wore a lot that my brother and sister wore.
Did you go to any Halloween costume contests?
Yeah,
was that a thing?
but it was mainly like a haunted house thing when I was a kid. We went to and then when I was a grown up going to costume contests, I had to design the costume myself. So, but one year I went as a fairy princess to a Halloween haunted house at the town hall. I grew up in a pretty small town, and I go through the haunted house and I come out crying. And my mom, and I'm dressed as a fairy princess, and my mom goes, "What's wrong? Was the haunted house too scary?" And I go, "No, I lost my wand." And she's like, "Your what?" And I'm like, "My magic wand, I lost it." Because she made me this wand.
And you wanted to get the wand back.
But I called it a wand.
Yeah. Well, this year, all the people who want to make any type of costume, they'll be able to do more than ever.
Yeah, it's actually so easy now to make your own electronic Halloween costume. And it gets easier every year when there's more projects and tutorials online. So there's really no excuse. Start now and you'll be all set.
Yeah. And speaking of probably one of the most popular Halloween costumes that we're going to see this year is something from the Iron Man trilogy. There's more than
3 movies. There's
there
comic
3?
books. Yeah, 3 movies. Yeah.
That's a lot.
Yeah.
From the Iron Man trilogy.
Right, I guess, of movies.
Yeah.
From the comic book. So we made, it's a popular project online to make too, but now that we have NeoPixel rings in the store, it made it really easy for us to make you an Iron Man reactor-ish type project that you can build at home. Why don't we just watch the video?
Yeah, look at that.
Thanks for the photo, John Jr. Halloween is coming up, and the next Comic-Con is always just around the corner. So you should channel your inner Tony Stark and build a wearable, glowing reactor. It goes great with your elaborate Iron Man costume or just under a white t-shirt. The circuit uses an Adafruit NeoPixel ring and Gemma to backlight some laser-etched acrylic. You can find the files on Thingiverse. Etch 2 pieces and color one in with a dry erase marker to block the light where the etching is. Stack them for a dimensional effect and add copper wire to look like coils. We diffuse the light with a bit of tracing paper, then attach the circuit to the face with glue. Strap it to your chest with a piece of elastic or build it into your Halloween costume. And you can follow our complete guide for this project on the Adafruit Learning System. What are you building for Halloween this year? Share your projects with us by using hashtag Electronic Halloween and subscribe for more costume tutorials from Adafruit.
Very cool. And you have it here.
Ooh.
Look at that. Oh, it even shows up nice.
Yeah, I can show it on the overhead too if you
Yeah.
want. So,
The overhead.
so Dano in Fab designed the laser cut pieces for this project, and he did a really excellent job. They're really nice. And so you can download the files on Thingiverse, and he so smartly made both the Iron Man 1 and 2 and then also the Iron Man 3 vector file, which is slightly different. It's like that triangle design you saw in the video.
Yeah.
And then Tony in what department is he in? In
Programming.
the programming
Dev.
department wrote this cute little animation that it's showing a little bit banded on the webcam.
It looks like there's
but-
a reactor in the center. Look at that.
Right, so the code just like fades them in and out a little bit,
Yeah.
with a little bit of randomness. They're looking a little flashy on the overhead. What happens when I do that? Ooh.
Yeah, and you can also turn on the backlight, and it does all sorts of
That looks
crazy
even
things, too.
weirder.
Yeah.
Here's the one, oh, that looks good. Here's one that it's in progress. Making another one. It's going to be a popular project here around the office, so they'll be
Yeah.
like, Becky, how can I make one? And I'll give them one of these or the laser cut pieces, and they can put it together themselves. So it's really fun. It's really easy. And here's on the. I'll turn this other light back on. Ooh, that looks nice with Gemma on the back. It's the first time you'll see me use hot glue in a tutorial, possibly ever.
Really?
I'm so disparaging of hot glue.
You just
But I
like-
show in the tutorial how you can use either E6000, my favorite clear and flexible adhesive that takes a day to dry, or hot glue in case you just want to do this on the day of your Halloween party.
I didn't realize your strong feelings against hot glue.
I have very strong feelings against hot glue. It is very rarely the right tool for the job, and you know how much I like to use the right tool for the job.
It's so used, though, for all the wrong things.
I know, that's why it bothers me. But I show how you can use hot glue, which, it goes against all of my sensibilities just because there are so many better adhesives. But anyway, you can use it for Halloween projects. Hot glue is totally
Yeah.
acceptable because speed is usually a major concern.
Yeah. And we have a couple of photos from the build.
Oh yeah, so this is a cool, we were just playing around with like the laser etched file that Dano made, and we discovered that it was Lamore's idea to color in the etching with the dry erase marker, but then we discovered if we layered an unmarkered piece behind it, we got like that cool, where the light like catches on the etching, but then is blocked by the other etching, so it's this neat kind of 3D, it looks like there's more depth to it than there actually is.
It looks very solid. It does look like there's something on there. And then here you are with your power plant.
So if you're a lady, you don't have to strap it on with elastic. You can just clip it onto your bra and you put the battery in your pocket. We did try to build this with the 2x coin cell battery holder to put it like on the elastic strap because it's very small, but it only powered the 17 NeoPixels for about an hour. So we upgraded to this 3 AAA battery pack, and then we just use one of our JST extension cables so you can tuck it in your pocket. And then it lasts for hours and hours and hours like that. Definitely through your Halloween party or the parade or whatever.
Excellent. Dano Wall, rising star
He did such a great job on this
in the
project.
world of wearable electronics already.
It's really nice.
Okay.
Thanks, Dano.
All right. Component of the week. What you got here, Becky?
This is the LED sewing kit. It's a kit I made before. It's similar to a kit I made before I came to Adafruit, but this one is better. It has more parts in it.
Yeah.
And it's basically enough stuff for you to sew your very first circuit. And the project that we launched it with is this LED hair bow. So there's no soldering. It's perfect for kids. There's no programming. The LEDs have a little chip inside them that make them flicker like a candle on their own. So you don't need to do any programming to make them have kind of some activity.
No downloading an IDE. No hacking the kernel.
Nope. Just some sewing and a little battery, and you're all set. And we have a video showing you exactly how to make that bow from this kit that we would like to show you now. Welcome to Wearable Wednesday. Today we're making a glowing bow you can put in your hair. It uses some candle flicker LEDs that have a slight twinkle of their own, which makes building the circuit super simple. And this is a great way to get into wearables. And when you're done, you'll have a cute accessory to wear or give. I promise it's super easy, and it's a great project for getting started with our Adafruit LED sewing kit. Come on, let me show you. For this extra large bow, select a grosgrain ribbon that's 2 1/4 inches wide and cut a piece to 28 inches in length. Gently heat the cut edges with a flame of a lighter or the barrel of an old soldering iron, and this will melt the polyester just a little bit, enough to stop it from fraying. Fold the ribbon in half and make a crease. Then take the cut ends and fold them up together 2 inches from the end of the ribbon. Fold the ribbon in half once more, this time matching up that fold you just made with the center fold, and you guessed it, crease your ribbon again. Then you can unfold your ribbon. To make the loops of the bow, find the first 2 creases and fold your ribbon over so they intersect, but then make a slight pivot so they're at a 45-degree angle. Then grab your center crease, fold that on top of the pile, again at a 45-degree angle, but in the other direction. Loop all of the slack to the back and align the next crease with the crease that's on the bottom layer, and those can be directly parallel. Kind of stick it in there like you're shuffling a deck of cards, so try to keep them all lined up. And then to make your last loop, take the remaining slack, bring it to the front at a 45-degree angle from its next intersecting crease, and you'll see it'll line up with the very first loop that you made. To give the bow some volume, make a valley fold lengthwise, then turn down the edges in an accordion fold to make a pleat in the center of the bow. Secure it with a tight stitch through all of the layers of ribbon so it stays cinched. Put your bow aside and pull out 2 LEDs and a coin cell battery. You can pinch these directly onto the battery to watch them flicker and identify the positive and negative leads. Bend the positive leads out at a 90-degree angle on both LEDs and cut 2 small pieces of heat shrink tubing. Place one over one positive lead and shrink it in place. Align the LEDs shoulder to shoulder, a small distance apart, and twist the 2 positive leads together. Repeat this process for the negative leads. Apply a small piece of heat shrink tubing, and then bend the leads at a 90-degree angle and twist the leads together. Bend your new LED assembly around so you can test it out on your battery and remember which lead is positive and which lead is negative. Mark the positive with a marker. Straighten the leads back out and use a pair of pliers to twirl the ends into little spirals. This will give you something to stitch through rather than trying to stitch onto a straight wire. Now it's time to put it all together. Grab your bow and align your LED assembly in the center pleat. You can either stitch or glue it in place. Then take a knotted piece of trim and glue the knot to the center of the bow. Wrap the trim around and flip the bow over and secure the tails of the trim at the back. Before we attach the battery holder, if you can't remember which end is which, you can always use alligator clips to verify the polarity of your battery holder and your LED assembly. So line up your battery holder on the back of your bow and use conductive thread to stitch through the lead of the battery holder to the front of the bow, then wrap several times around the LED lead spiral you made earlier. You can go back and forth as many times as you want, just end on the back of the bow in order to stitch several times around the battery holder tab before tying off your conductive thread with a knot. I like to seal my knots with clear nail polish so they don't come undone. And for more tips on conductive thread, check out our video on the subject. Repeat the stitching process to attach the other side of the battery holder to the other LED leads. Once you've cut off all your thread tails, it's time to test out your circuit. Put in the battery, and if your LEDs don't light up, check to see if you have your battery holder installed backwards. You can glue a hair clip in between the battery holder and the ribbon bow, but you could just as easily make these into shoe clips or sew it onto a bag or anything else you'd like. Make it your own by switching up the color and size of your bow, and it'll match any outfit. Just expect to get a little extra attention at your next party. Share this video with a young engineer you know, and share your wearable electronics projects with us on our weekly show and tell on Google+. Subscribe to our channel here on YouTube so you never miss a video, and I'll see you on another Wearable Wednesday.
Okay. I like the video because you emerge and then you go back down to wherever wearable electronics people go to.
To take a nap under the desk.
Take a nap. Okay.
So I hope you liked that.
My LED blankets.
Yes. I hope you like that project. I've done, in the past, lots of projects that are similar, or use a similar circuit that just aren't Adafruit projects, but I mean, I'm going to have to redo them eventually anyway. I did a pair of LED toe clips that are like ruffly things, and you can wear them like as part of your bridesmaid's outfit. Same circuit. Embroidery of some fireflies, same circuit.
Yeah.
Embroidery of a lighthouse, same circuit. You could use it to make a robot Halloween costume with flickering eyes.
Yeah.
And lots of other things. So if you're looking to like get your, teenager or even younger into electronics, and your kid already likes crafts, this is a good kit to get.
It's a gateway project.
Yeah, gateway project.
All right, and then a couple other shots of the sewing kit.
Those are all the supplies you need. Oh, look, this will be today's the second time I showed you how to use hot glue. This would be the first time is in a craft like this. And then there's lovely Kelly and Rissa on the Adafruit team modeling the hair bows.
Okay, next up, just a reminder, the code is Halloween, 10% off everything in the Adafruit store in the Flora and Wearables category until 11:59 p.m. tonight. Get on it. Get your Halloween costumes going.
And if you want to win an LED sewing kit, we're giving the LED sewing kit away today to people who have asked questions.
If you want to win something in the future.
Yeah, if you want to win, that's what I meant. If you want to win something in the future, you post a question either in the comments below or on Twitter or Google Plus or Facebook or Carrier Pigeon. And if your question is included in a future show, you will be entered in that show's giveaway. So these are all the people who asked today. They will be entered in a giveaway to win Jan LED sewing kit.
Okay. Material spotlight.
It's a quickie today.
Yeah.
The quickie button, awesome me.
Yeah, that's a word.
This is conductive Velcro, and I like to use it as a switch. It's a standard hook and loop closure type material, both a fuzzy loopy side and a hook side, and we sell it in this little piece. It's silver plated, so it does oxidize after like a year or 2 years of being out in your project if it's not in a plastic bag, but otherwise it acts just like Velcro. The fuzzy side is very fuzzy, so it's not ouchy against your skin. It's just a really neat material, and I have a photo of a past project that I used it on where I used it as a power switch, actually.
That's nice.
It can't throughput a ton of amperage, but this project I was making was just an LED bike patch. Here's a GIF. Ooh, nice. So I used a little flap that had the conductive Velcro on it, and if you go back to the other photo, you can see that the flap will bridge the two little tabs and close the circuit there and allow electricity to flow and turn on the circuit. So you can use it for that. You can use it as a sensor, like, I took my jacket off, that disconnected the Velcro, and I can sense that and make something happen. The TV Be Gone jacket that uses a zipper switch made out of conductive thread, you could also use conductive Velcro as a switch in that case to trigger your TV Be Gone to go off. It's just useful for all kinds of things.
Okay, next up, questions and answers. This is my favorite time. People asking questions.
And I give you answers.
All right, the first one is from David. Could you use a Gemma for the Firewalker sneakers or chameleon scarves? If so, what are the limitations?
You can use the Gemma for the Firewalker sneakers as they are now. The animation that Phil B wrote for the Firewalker sneakers may not fit on the 5.5K of flash memory you have available to you on the Gemma. So you might have to write a different animation to fit, but using a Velostat or an analog sensor works fine on Gemma, and controlling NeoPixels works great on Gemma. So technically, yes. And then the chameleon scarf, we don't have the I2C sensors working yet on Gemma, but there's hope. Yeah. I'm thinking there's hope. Because Phil B's been working on, if you look at the Adafruit Learning System right now, he did a Gemma matrix, I2C matrix backpack pendant. Yeah. And so he's kind of working on the I2C stuff on Gemma, so coming soon, stay tuned on that.
One of the cool things about these platforms that we release is there hasn't been a ton of work done on them. So we'll get our tutorials getting started, and we'll have a few projects, but then the open source community comes in, and then all of our staff starts to work on it, and then we kind of push the max of what these things can do, and then the chip manufacturer like, wow, that was really cool what you guys did, and like you released all the code. So although like Gemma is $7.95, you get so much more value. It's cheaper than a movie ticket.
Way cheaper than a movie ticket. Why are movies so expensive?
Yeah.
That's why I haven't seen Iron Man.
Yeah. It's like $80 to see Iron Man altogether. Hi guys, can I power a 60-pixel NeoPixel LED strip that needs 5 volts and 2 amps?
How can I power? How can I power a 60-pixel per meter NeoPixel strip that needs 5 volts and 2 amps? With a 5 volt and 2 amp AC adapter.
Yeah, we have one.
Yep.
Okay.
That doesn't sound, I don't recommend you wear 2 amps worth of current draw at this time. Tethered to the wall, maybe, when you're
Next
dancing.
up from Curtis. How well does the conductive thread fabric stand up to athletic movement? You mentioned the running at the end of the show, but I was curious if conductive thread fabric was used in an application where the material is subject to sweat and or hot, cold temperatures. Would it break down fast? Sorry, 2 questions in one. That's totally okay.
This is an interesting question that I have talked to my buddy Bryce at Adidas about.
Yeah.
And I don't worry, I don't have any proprietary information to give you. But he was talking to me about the design constraints. He's like, oh, I'm so jealous. You get to make like a plush controller with conductive fabric, and if the fabric tarnishes in a year, like, it's not a big deal. But he's working on like the shirts that the athletes wear with the conductive fabric heart monitors in them, and it has to last for an entire season. So like they don't expect it to last forever for the athlete, but they expect it to last through an entire training season, and that's a lot of sweating through conductive fabric. And if the conductive fabric's made out of silver, it's gonna tarnish.
Yeah, they did tell me something proprietary, and I'm gonna get in a lot of trouble for saying this. You know what actually does make people go faster? Little racing stripes on the side of the shoe. And I'm sorry, Adidas, that I broke the NDA, and now Adafruit's going to get sued. So it was worth it. I had to get the information out. It wants to be free.
It does want to be free. Racing stripes on your shoes. So the conductive thread that we sell is stainless steel, and it won't oxidize. So if you sweat through your wearable and you're using conductive thread for power or signal, you're going to short your traces with sweat. If you're designing a garment that uses conductive thread, like the sparkle skirt, you don't want to sweat through it. So I'm trying to think of a case when it's touching your body, and the only thing I can think of is like heart rate monitors made out of conductive fabric. So they will break down faster than if they're just touching air, because your body's fluids are pretty corrosive.
Yep. All right. Next up, Scott writes, I might be posting this wrong place, but I am going to make the NeoPixel ring pendant. I was wondering if it's possible to put an on-off switch between the battery and the main board. If so, what would be a good button to use?
I like our tactile on-off switch, but it's a little large. If you don't mind the extra space it takes up, you can solder that in. Just cut one of the leads of your battery, which is advanced. I don't recommend beginners ever solder to their lithium polymer battery. It's just not a good idea, because if you're not paying attention, it could short and catch on fire.
Not fun.
So for advanced users only, yes, you can solder a switch to your lithium polymer battery. Just use lots of heat shrink tubing. I like our tactile on-off switch, but it's a little chunky. But it is just press once to be on, press once to be off, and it's got a flat back on it.
All right.
Maybe we'll look for smaller switches like that.
Next up, I'm working on a pedometer project for my dog with Flora NeoPixel ring and the Flora LSM303. The hardware is pretty much done, but I wonder if you have any tips on the activity detection on the programming side. This is relevant to
tell them how you planned to do the checking on your dog pedometer, Phil.
Well, it's funny. So last night I was with some friends from Google, and I worked with them in my previous career, and a very large dog food company was our client, and we actually came up with a dog pedometer, and I wore it on me, and I also had a dog. And you can do lots of different things. What I would say is you're going to want to record the current activity of the dog and do lots of different stuff. So go for a walk around the block. Go for a run, and measure the activity reported. And you can do a lot of different ways. So like there's tilt switches that you could like log. There's a GPS.
He's using a LSM303 accelerometer.
Yeah, there's all different ways. Like if you wanted to go low cost one day. What I had done is I eventually broke it down to different dog breeds and different types of activity. And then once you get that, you have a range of not a lot of activity on average to a lot of activity. And one of the things that I did, which I still think is going to be one of the things we see the pet owners, is a leash or something that glows green to red. So green means all the activity, Fido, got worked out. Yellow, could still use a little bit of walking. Red, that's some pet guilt there. Your pet guardian.
You know, I would love to see that on other dogs, because like a lot of times, because I have a big dog, and so like she incites a lot of dog reactions when we're out. Like other dogs react to her.
Yeah.
And sometimes not in a great way. They might be intimidated by her or whatever. And a lot of times dogs misbehave because they haven't gotten enough energy, enough exercise.
You'd see this red light dog going by, red light dog.
Yeah, and I'd be like, oh, that dog is pent up. Like Caesar Milan would be like, put this thing on your dog. Red dog means you don't like, well, I take Fido for a walk every day.
Yeah.
Cesar Millan would say, but your dog's not getting enough exercise.
Becky, are you the pack leader? Are you?
I am.
You're the pack
I'm
leader?
an excellent pack leader.
Okay.
But still, I do feel
Just
guilty
checking.
when my dog is like, I want to go play. Like,
Yeah.
and you learn to read your dog's body
Yeah.
language, but if you don't, you could use a dog pedometer. So as far as specific programming for your accelerometer, I would like log the spikes in the the highest and lowest points that the different readings get you, and then and make a log of like, okay, we went for a run and this is what that data looked like. We went for a walk and this is what it looked like. It sounds hard to me, but I'm not an excellent programmer, to actually get the accelerometer to very clearly tell you how many steps the dog takes, which is what the literal meaning of a pedometer means. But you can definitely track activity.
Yeah.
Maybe you could combine it with a GPS and see like how you could estimate how many calories your dog burns over.
One of the cool things is since you're making this is different than the thing that I was working on because it had to be figured out in advance. You're making this, you can tweak it, and you can always go back. And I think data logging and just doing analysis is fun. And a pet is great. A pet and a science project is even better.
I have this idea for a GPS project for my dog. I mean, we already made a GPS dog color project, but I want to make it again smaller with Flora stuff because it was before Flora was out. I take my dog for off-leash walks through the park on the trails, and we go for like a 4-mile hike, and she's running backwards and forwards and backwards and forwards, and I'm just walking. And I map our walk on my phone with a dog walk mapping app. But I want to also log the GPS on the dog and then compare the two maps and see how much more distance she traveled than me.
Yeah, that's a good idea. Yeah, all this stuff that people come up with in their minds and that they want to do on the weekends and they have access to this stuff is what you'll see in the future. So this will totally be part of, there's a Fitbit dog group, people who put Fitbits on their dogs. There's all sorts of things. And I think in pet electronics, if you look at the Adafruit learning system, we have more pet electronics projects than any other learning system online. That's a challenge.
My dog loves electronics, by the way.
Yeah.
So does MOSFET. He's named after electronics.
He grew up around electronics, and LEDs don't bother him. He's kind of uninterested in lasers now, because he's seen so many lasers. He's like, I was at that concert. That's okay. Yeah. All right, it is time for a giveaway. We're going to give away an LED sewing kit.
We answered all the questions.
We answered all the questions.
Oh, okay. We're giving away this LED sewing kit. I have the people who asked questions today are in my little bin here. We totally fairly pick a random piece of paper.
Yeah.
And it's David Deaton.
Congratulations.
He asked about, can I use Gemma for the Firewalker sneakers? David, this is your LED sewing kit. You can email support@adafruit.com to claim your prize, and I'll also send you a message on YouTube. Yeah. So if you would like to be entered in a giveaway, ask us your best questions about wearable electronics. They could be about a material, about a component, about a project you want to build or are working on now. Just post them up on YouTube or Twitter or Google Plus or Facebook or all of those places, and we'll collect them throughout the week and include them in next week's or a following week's show. You'll be entered in the giveaway, and you'll hopefully tune in again, which we would like to see you again next week on Wearable Electronics with Becky Stern.
All right. See you guys next week.